This video takes a look at Module 2, Lesson 5, Understanding Subtraction of Integers and Other Rational Numbers. So Lesson 5 is the first lesson in Module 2, where we are transitioning away from adding integers to subtracting integers. Today you guys are going to justify the rule for subtraction. You've got this lesson when you are able to accurately describe the rule for subtraction and apply it to solve subtraction expressions. Our standard is 7 NSA1. Apply and extend previous understandings of addition and subtraction to add and subtract rational numbers. Once again, this lesson is the first time we're focusing on the subtraction component of this standard. All right, so to open up and start with Lesson 5, this example, obviously we're not in the classroom, so we can't really play the integer game. So what I'm going to do is we're going to imagine and do a mock integer game. Now I'm going to fill out the first row so that it is clear what I expect, and then you guys can go through and fill out the rest of this independently. So round 1, say we start and we have a total of 12 in our hand currently. Then we select 3. Our result, or where we're currently at, is 15. Because 12 plus 3 is 15. Now, our score, or our total, increased by 3. So in this description column, you're going to write what happened to your score or your total. Did it increase? Did it decrease? Okay, and by how much? Now, the second action will be given to you. We discarded 10. Okay, so if we are at 15, because our score increased by 3 and we discarded 10, now we are at 5. Because 15 plus a negative 10 is 5. And then we are once again going to write what happened. Our score or our total decreased by 10 because we discarded 10. All right? Now, whatever your new result is goes here in your next round, and you keep going. So what I want you to do is fill out the rest of this table using the information that is given. When you are done, come back and check the video and make sure you did this table correctly. And then afterwards, we're going to discuss the questions on the next page. So as you're working through, consider what you are actually doing so that you can adequately understand what's happening on the next page. This is what your integer game table should look like. So take a second, pause the video, read through that. Make sure you have it all labeled correctly. Now, we are going to we're going to make some connections by answering these questions. Now, how did selecting a positive value card change the value in your hand? So it increased, and I'll underline increased, the score by the value of the card. So if we go back, right, if I selected a positive 3, it increased my score by that amount, right? If I was at negative 5 and I selected 1, it increased my score by 1, so on and so forth. Now, how did selecting a negative decreased the score by the absolute value of the card? Okay, so if I go back and I selected a negative 2, it decreased by the absolute value of negative 1, which is 1. So it decreased by 1. Here, selecting a negative 7 decreased my score by 7. Okay, now moving down to 3, how did discarding positives change your card? It decreased it decreased the score by the value of the card. So getting rid of a positive decreased the score. And how did discarding a negative? It increased the score by the absolute value of the card. So there seem to be some connections here. Discarding a positive seems to decrease, just like selecting a negative seems to increase. And then selecting a positive increased, just like discarding a negative increased. Now, what operation reflects selecting a card? Selecting a card is addition because you're adding something on. Now, discarding a card is subtraction. You're getting rid of something. Okay? Now, based on the game, can you make a prediction of what happens when subtracting a positive integer? So take a second and make a prediction for A and B, and at the end, we are going to review these predictions. What I am going to say, and once again, your prediction may be different, the result of the hand will decrease by the value of the integer based on what I noticed at the top. And for subtracting a negative integer, the result of the hand will increase by the absolute value of the negative integer. So that's just based on what I noticed from the table as we are working through. Your prediction may be different, which is fine. We are going to review it at the end. I'm not saying my prediction is correct by any means. All right, now we're going to take a look at an example. So we have these two cards. Let's say we pulled these playing the integer game. We got a 4 and a 2. Now, 4 plus 2 is obviously 6. Don't need to be a rocket scientist to figure that one out. Now, we are going to model it using the number line here. So I would start my tail at 0. I would go to 4. And then I would start my next tail right where the last tail ended, or the last vector ended, and add 2. So this gets 6. Now, we are going to discard or subtract a positive card. That is the same as subtracting a positive number, which will decrease the value of the card. Okay? So, getting rid of this 2, discarding this 2, is the exact same as adding this negative 2. Now, let's show what both of these look like. This ends up being 4. I can show this on my number line. I am at 0. Let me make sure I color this for you guys. So I'm at 0, going to 4. I'm adding 2 and going here. Now, I'm then essentially taking this and I am subtracting or removing the 2. Okay? So I'm getting rid of this. So I am just left here at 4. Okay? It's essentially telling me to get rid of this second arrow or get rid of this second vector. Now, instead, we can look at it like this, which I'll tell you will get 4 as well. You can start, similar vector will start by going to 4. Then it will add on to, and then subtract away that 2. And you end up at 4. So basically, what I'm noticing here is subtraction, which is what we did up here. We just took away that 2. We discarded it. We got rid of that 2. Seems to be the same as adding the numbers opposite. Seems like adding a negative 2 is the same as just subtracting 2. So let's use that to fill in these blanks. Removing or subtracting a positive card changes this way, the same way as adding a card whose value is the additive inverse or opposite. In this case, adding the corresponding, and this is going to take up some room here, negative, such that 4 minus 2 equals 4 plus negative 2. Okay? Subtracting a positive q value, and remember, q is the second number, is represented on the number line as moving to the left on a number line. Okay? So, subtracting is the same as adding the opposite. So 4 minus 2 is the same as 4 plus negative 2. So subtracting that q value, that second integer, is the same as moving to the left on a number line. Example number 3, we're going to focus on subtraction of a negative number. So follow along with me as I complete this diagram. So the first problem shows that I have a 4 plus negative 2 in my hand. So I'm going to start at 0. I'm going to draw my tail, my vector, out to 4. And then I'm going to pick up where that one left off and move 2 units to the left because that second card is a negative. And I end up right here at positive 2. So the sum of 4 and negative 2 is 2. Now, let me answer this question here. How does removing a negative card change the score or value of your hand? If I discard it or removed, meaning get rid of, the negative 2, my score would increase by 2 because I would still have 4 left in my hand. So, if I want to write this as an expression or an equation, 4 plus negative 2 minus negative 2. So that minus negative 2 means getting rid of that negative 2 equals 4. Okay? So taking away or subtracting negative 2 causes my score to increase by 2. Okay? So subtracting a negative actually increases the score. All right, moving down. 4 plus negative 2 minus negative 2. So let's try and model this one now on our number line. So we're going to start by creating our vector at 4. Then my second vector would go back negative 2. And then it's telling me to subtract away this negative 2. So it's telling me to get rid of this vector. So I am subtracting or removing the negative 2 vector here. So really I'm ignoring that, and I notice I end up at 4. So the answer to this equation has to be 4. Okay, I'm subtracting that negative 2, meaning get rid of that negative 2 vector. Or I can look at it like this. I will start by drawing my 4 vector out here. Then I have negative 2. And then I have positive 2. So these are essentially canceling each other out here. And I end up right at 4. So the answer to this expression, this equation here, is 4. It's an equation, by the way, not an expression because it has an equal sign. Expressions do not have equal signs, whereas equations do have equal signs. So let's fill out these blanks here. Removing or subtracting a negative card changes the score the same way as adding a card whose value is the additive inverse. Fill this out correctly. Or opposite. In this case, adding the corresponding, it's going to be a little bit longer here, positive, such that 4 minus negative 2 is the same thing as 4 plus 2. Subtracting a negative q value is represented on the number line as moving to the right on a number line because it is the opposite of subtracting a positive q value. Okay? So what I like to do, let's say we have 4, and I'll write this in a different color here. If I have 4 minus negative 2, in math, if I have these two negatives back to back like this, which really I'm viewing this as 4 negative negative 2, I just combine it like this and make a giant plus. And I just make this 4 plus 2. So if you have those two negatives back to back, or two minus signs, whatever you want to look at it, back to back, all you have to do is change it into a big plus, because subtracting a negative is the same as just adding the opposite. All right? So keep that in mind as you work through. And with that said, the rule of subtraction is right here. Subtracting a number is the same as adding its additive inverse. Okay? So sometimes this is taught similar to division of fractions as keep, flip, change, or KFC, or keep, change, or keep, change, flip, whatever you want to think of it as. Because you keep the first integer the same and you add the opposite. All right? Now, I will tell you here how I actually look at these problems before you get started. Let's just look at this first one. I don't think of this as subtraction. How I think of this as having 8 and then negative 2. 8 and negative 2 gets 6. And then if I see these two back to back like this, I change it into a giant plus. But what I want you to do is think of your own strategies for these and answer exercises 1 through 3. When you are done, come back and I will walk through how I'm thinking through these different problems. Okay, so for 1A here, there's a few ways you can think of this. So I need you to listen and then figure out what makes the most sense for you. Now, there's a very direct... First of all, we know this answer is 6. 8 minus 2 is 6. The important part is not the answer as much as the process. You can use just keep, flip, change. And what that would look like is the 8 stays the same. The subtraction changes to addition. And then the positive 2 becomes its opposite, which is negative 2. And then just knowing 8 plus negative 2 is 6 is one way to think about it. Okay? Now, how I think about it is I never think of subtraction. Okay? I look at this as having basically a negative 2 and a positive 8, which is essentially what this is doing. Positives and negatives, I know they cancel each other out. Okay, they're kind of at a battle. They're at like a war. I have my positives versus my negatives. Now, I have 8 positives and 2 negatives. I have more positives, so I know my positives are going to win. And then I think, how many more positives do I have? I have 6 more positives than I have negatives. You get that from subtracting. So my answer is positive 6. Now, down here, if I want to apply that same strategy, I have 4 positives and 9 negatives. I know my negatives are going to win. They're stronger, and I have 5 more of them than I have for my positives. Now, if you just want to go forward and use the keep, flip, change method, we know here that 4 plus negative 9, we have different signs, so we need to subtract and find the difference. and then my negative has a greater absolute value. So that's what's resulting in the -5. Okay? This one, if we use our keep, flip, change, keep, flip, change, we're going to end up with two negatives added together. So you find the sum and you keep the sign. That gets a -10. Now, how I think of this problem in my mind is I think of having 3 negatives and another 7 negatives. That's 10 total negatives. Okay? That's how I'm actually thinking of this problem. Now with D, when I see those two negatives back to back, what I do is I just switch it to a plus. So I'm at 9 negatives and 2 positives. That gets -7. Okay? Or you can think of it as, oh, I have different signs, so I need to subtract, and I need to keep the sign of the number with the greater absolute value. That's what gets us -7. Okay? Moving down, I'm just going to list the differences here. This is 3. This is 19. And then this ends up being -6. All right, two equivalent expressions that represent this. Now, there is a challenge question in your problem set that relates directly to this. Now, if we have an airplane at an altitude of 25,000, that's a positive 25,000. Now, it dives to a depth of 600 feet below sea level. So diving is a negative or a subtraction. And then we're going 600 feet below sea level. Another way to look at this is the 25,000 plus just 600. Because subtracting a negative is the same as just adding. The difference in their elevation is 25,600 feet. Okay? You got two different expressions. Both of these are going to be equivalent to 25,600 feet. All right, lesson summary. The rule of subtraction here, and this is kind of your goal for the lesson, is to understand this and then apply it to be able to subtract. Subtracting a number is the same as adding its opposite. So you can always change that subtraction problem to an addition problem. Okay? Now, removing or subtracting a positive card changes the score in the same way that adding a corresponding negative card would. So that actually fits with the prediction I had at the beginning. And removing or subtracting a negative card makes the same change as adding the corresponding positive card. Okay? The main thing I want you guys to know is this rule of subtraction and being able to apply it. Subtracting is the same as adding the opposite. So subtracting a Q, that second value, you switch to adding the opposite. Okay? So what I want you to do is go through now, and we're at that state where we're at the problem set. This is a chance for you to gauge, A, do you know the subtraction rule, which is up here, that needs to be committed to memory, and can I apply it? When you are done with these problem set questions, come and check your work with the video, and then you'll be done with this lesson on the subtraction of integers. For question 1 in our problem set, remember the word difference means subtraction. So what it's essentially telling you to do is subtract 4 from everything, from each number. And we have this nice table organized so we can practice, this idea of using adding the opposite. Okay? So if we have 10 and we're subtracting 4 away, it's 10 minus 4. The addition expression would be 10 plus -4, getting an answer of 6. 2, if I subtract 2 minus 4, by the way, the order when you subtract matters. 4 minus 2 is not the same as 2 minus 4. So keep that in mind heading forward. 2 minus 4 turns into 2 plus -4, which is -2. Okay? If you are taking away more than you start with, you're going to end with a negative difference. Okay? You can see the rest here. I don't need to read them to you. Just make sure you did these correctly. Moving down to number 2. Finding the value of each hand and who's winning or who wins. Remember, who wins is who's closest to 0. So for my hand, that is equal to a -3. And the partner's hand would be -1. So the partner wins because -1 is closer to 0. It's only 1 unit to the left of 0, whereas -3 is 3 units to the left or below if it's a vertical number line 0. Okay? Now, B, find the value of each hand if you discarded the -2 and selected a 5, and your partner discarded the -5 and selected a 5. So if this happens, your hand will now be 4, and your partner's hand would now be 9. Here is the subtraction. In this case, I used equation to represent. You could have still done addition. That would be fine. Just remember, discarding the -2 would be the same as adding a -2, okay? Or subtracting a -2. These basically work to turn into addition. Same thing as discarding a -5 is the same as adding 5. But now if this move would happen, you would now win because 4 is closer to 0 than 9 is. It has the smaller absolute value. All right, 3A is 14. 3B is 14 as well. C is -8. D is -37. And E is 75. If that went too fast, go back and review. Make sure you got those correctly. 4, what this means, and it can look a little complicated, but this is essentially our subtraction rule, okay? Subtracting a number, P minus Q, any numbers, is the same as adding its additive inverse, or its opposite. So an example here, if P is 4 and Q is 6, 4 minus 6 is the same as 4 plus -6 because -6 is the opposite of 6, okay? But this is essentially our subtraction rule written out in mathematical terms. P minus Q, or subtracting two numbers, is the same as keeping the first number the same and adding the opposite of the second number. Number 5, you had to choose some integer between -5 and -3, or -1 and -5, excuse me. I ended up picking -3 as that point. And then we needed to go through and answer these 3 questions, okay? Obviously, your answer will look different because you could have picked -2, -3, or -4, because those are the 3 integers between -1 and -5. But for me, if I pick -3 as P, -3 minus 5 is -8. -3 minus 4 plus 4, that ends up getting -3 because essentially this -4 and +4 are additive inverses. They cancel out. So point B will be right where point P was, right where we started. And point A is over here, by the way. Now, point C, -3, that means the opposite of -3. So this part here turns to a +3. This turns to a +7. So we essentially have 3 plus 7, which is 10. Keep in mind, depending, once again, on what value you picked for P, whether you pick -4 or -2, your answers will be a little bit different. Now, our challenge problem is very similar to the problem. If I go back a few slides, it is the same essentially as this problem. So is it a challenge? Maybe slightly, but if you just flip back a little bit in your notes, you should be able to answer this. The 2 equivalent expressions are 26,000 minus -700, which would be the same as 26,000 plus 700. Using that keep, flip, change, these 2 negatives make a positive, basically. The difference ends up being 26,700. So, for this lesson, you should be able to apply our integer rule for subtracting right here. P minus Q is the same as P plus -Q. Know that. Know how to apply that to be able to solve subtraction expressions and equations. If you can do that, if you know the rule and can apply it, you're good with this lesson. You're ready to move forward.